Hi, dear students. I hope you will be absolutely fine. Today's topic under discussion is phonation. You will be greatly astonished and surprised to know how complex you are. Today, the topic under discussion is phonation, and we are going to discuss the very first slide. I have especially created 45 slides in order to convey today's topic to my dear students with respect to phonation. Let's stream through, let's go through the very first slide. Open up your mouth and make a sound. I don't care what it is. Scream, sing, recite, or sing your favorite poem. Speak up, say oh, or sing a song. What are you doing is actually phonation. Phonation is the production of vocal sound and speech. Whatever we say, whatever we speak, whatever we utter is termed as phonation. You know, through our lungs, when we are about to speak, the air travels, and if it travels faster, we are able to produce higher sounds, and if it travels slowly, then we are able to produce whispers. It entirely depends upon the pressure of air which is actually coming out of your lungs. It vibrates the vocal cords, and through the vibrations the sound is produced, and this process for the production of the sound is termed as phonation. Okay, next slide. Expression through vocals may seem effortless and easy, but it actually comes from a delicate and complicated system of laryngeal muscles and ligaments. Let's take a look at them. Oh, by the way, you can stop making that noise now. Here, you must be well familiar with the larynx. This is basically the voice box in which there are vocal cords and vocal folds. They vibrate, and through the vibrations, sound is produced. And there are also ligaments which connect the muscles of the body to the bones, and same the bones are connected to the muscles with the help of ligaments. Laryngeal skeleton. Laryngeal skeleton is located between the root of the tongue and the trachea. The laryngeal skeleton is comprised of 9 cartilage attached to the structures of the axial skeleton. Here, the cartilage bones are those bones which are soft, not so hard, like the bone you have in your ear and nose as well. And there are also other bones which are softer. They are not harder. You have also cartilage bones on the kneecap, on your knees, in form of a kneecap. This is the cartilage bone. So cartilage bones are also placed in our laryngeal skeleton, and these help in the production of the sounds. So there are basically 9 cartilages attached to the structures of the axial skeleton: epiglottis, thyroid cartilage, cricoid cartilage, to arytenoid, and to arytenoid cartilage, to carniculate cartilage, and to cuneiform cartilage. These are connected by ligaments and moved by numerous muscles. Numerous muscles, multi muscles, and number of a particular number of muscles takes part in producing the sound. As you know, in your previous lectures, we have already discussed that there are 100 different types of orofacial muscles which involve to produce the sound. So this is very complex structure of human being, and same is the case with rest of the animals and the other organisms who can produce sounds. But in clear sense, humans are really complex. You are really complex. If we take stock the anatomical structures of human beings, the movement of the laryngeal skeleton opens and closes the glottis and regulates the degree of tensions in the vocal folds. The air passes through the folds, they produce sound, tension levels controls the pitch and volume. When there is a movement in the laryngeal skeleton, it opens the glottis and regulates the degree of the tension in vocal folds. And if the degree of the tension is regulated in the vocal folds, then vocal folds actually vibrate. They show some type of oscillations, and then the air passes through the folds. These also open and close. Air passes through the folds, and passing air vibrates the folds, and hence the sound is produced. But here arises a question that some people have sounds different to others. The sounds of all human beings are not similar. Sometimes some people have louder voices, and some have light voices, and there is also a different and a quite vivid difference between the sounds of males and females. So it entirely depends upon the tension levels controlled by pitch and volume. Volume can also vary from different humans to from different humans. So if a person is speaking, his or her voice is, the volume of his or her voice is higher, whereas there is a particular type of pitch which creates the difference between higher and lower sounds, the loud sounds as well. The laryngeal muscles are a set of muscles in the anterior neck responsible for sound production. The intrinsic muscles of the larynx function to move the vocal cartilage and control tensions. They are inverted by the vagus nerve. Basically, this is a nerve which stimulates the vocal cords and the vocal cartilage to control the tension in order to have a full control over how our voice is to be phonated. So this is vagus nerve, and all systems of human body are connected and well coordinated, and all this happens under the control and instructions of your brain, and there are basically some nerves which connect your body parts to the directly to the brain. There is also a central nervous system, and it can also be a peripheral nervous system. So these nerves can play the role of the connection and coordination between your brain and body parts. To understand the term phonation has slightly different meanings depending on the subfields of phonetics. Phonetics is basically the branch of science in which we study how sounds are produced. And phonation is basically the production of the sounds. The produced sound is to be termed as phonated sound. Among some phoneticians, these are very expert people who have the knowledge that how sound is produced, how sound will produce, and what was the quality of the sound, what was the pitch of the sound, and what if the pitch is increased or decreased, what things are responsible for the phonation. So these are called phoneticians. Phonation is the process by which the vocal folds produce certain sounds through vibrations, and this is definition used among those who study laryngeal anatomy and physiology and speech production in general. This was the basic definition understood by all the phoneticians and those people who study physiology and speech production as well as laryngeal anatomy. Anatomy is basically of two types. It is the branch of biology as well, and it deals with the study of human body parts, or body parts of all living things. If we talk about the external parts of the body, we are going to discuss the external anatomy, and if we discuss the internal parts of the body of living organisms, we directly mean that we are going to discuss the internal anatomy. Phoneticians in other subfields, much as linguistics, phonetics. Linguistics is basically the scientific study of the language, and those people who scientifically study the language are called linguists. So, in linguistics phonetics, we call the process voicing. Phonation can also be termed as voicing, and use the term phonation to refer to any oscillated state of any part of the larynx that modifies the air stream, of which voicing is just example. So, voiceless and supraglottal phonations are also included under the definitions. Sometimes some people are deaf and dumb. They can't speak, they can't express what they think, and sometimes they are unable to produce the sounds. This is just due to the abnormal anatomical changes in the laryngeal muscles and in the formation of the voice box, termed as laryngeal muscles and laryngeal regions. So that's why they are unable to produce the sounds. Voicing, the phonatory process. Phonatory process means the process in which sound is produced. It can also be known as voicing. It occurs when air is expelled from the lungs. Phonatory process occurs when air is expelled from the lungs to the mouth. It passes through the glottis, through the larynx, and it vibrates the voice box or the vocal folds or vocal cords. Then the sound is produced. So when the air is expelled from the lungs through the glottis, creating a pressure drop across the larynx, when this drop becomes sufficiently large, the vocal folds start to oscillate. The minimum pressure drop required to achieve phonation is called the phonation threshold pressure, which can also be abbreviated in the form of PTP. Sometimes we speak less loud words, we whisper. Sometimes we just want to convey our message or our speaks and our talks to the person who is very near to us. So our PTP and our phonation threshold pressure is very less comparatively, and if it increases, it will produce the louder sounds as well. And for human with normal vocal folds, it is approximately 2 to 3 centimeter H2O. H2 is the molecular formula of water molecule. It is one molecule of water, H2O. It means hydrogen. There are two types. There are two molecules of hydrogen, and one atom is also included. One molecule of oxygen, and there are two molecules of hydrogen. We can also say that there are two atoms of hydrogen and one atom of oxygen. When these combine, they form water molecule. When atoms are combined together, it becomes a molecule. So we can say there are two atoms of hydrogen and one atom of oxygen. The motion of the vocal folds during oscillations is mostly lateral, though there is also some superior component as well. However, there is almost no motion among the lengths of the vocal folds. The oscillation of vocal folds serves to modulate the pressure and flow of the air through the larynx, and this modulated airflow is the main component of the sound of most voiced phones. Phones basically is also derived from word phonation. We often say that it's the phone call. Basically, a phone call means we hear only phone or only sound. So this is a word taken from the phonation, and this is a biological process in which humans are able to speak or to talk. The all living organisms produce different sounds through phonations, and it's only just because of the oscillations of the vocal cords, and these regulate the pressure and flow of air through the larynx. And if the air is passing abundantly, it means you will be able to produce the louder sounds, and if air is passing in less amount, it means we can say that there is a lesser amount of the sound we are going to produce. So this process can easily be understood from this lecture. Okay, next slide. The sound that the larynx produces is a harmonic series. In other words, it consists of a fundamental tone called the fundamental frequency, the main acoustic cue for the percept pitch. Acoustics is a branch of physics which deals with the study of the sounds, how sound is produced and how sound is phonated. So overall and on the whole, the study of sounds is called acoustics, and it is basically the main acoustic cue for the percept pitch, accompanied by the harmonic overtones, which are multiples of the fundamental frequency. There can be a variety of sounds, and the sounds can vary from people to people. According to the source filter theory, the resulting sound excites the resonance chamber, that is the vocal tract, to produce the individual speech sounds. The vocal folds will not oscillate if they are not sufficiently close to one another, or not under sufficient tension, or under too much tension, or if the pressure drop across the larynx is not sufficiently large. It is very obvious from these lines that there is a theory, filter theory, which enables us to understand that if the air which is which is coming from our lungs, and if the pressure of the air is not much enough, which is required to vibrate the vocal folds, we will be unable to produce a sound. Secondly, if you want to produce the louder sounds, it means you need to push the air more speedily from your lungs to the mouth. In this way, you will speak up, you will utter the louder sounds. So, as louder sound, so if you want to produce the louder sounds, you need to have much speedy air coming out of your lungs to the throat. So if the pressure of air increases, the sound of your voice also increases. So this is basically the directly proportional process. They are directly proportional to each other. If one thing is increasing, the other one is also increasing, and if one thing is decreasing, the other thing is also decreasing. Suppose if the pressure of the air is increased, your phonation is also increased, and if your pressure of the air coming out from the lungs to the throat is uh, increasing, then you will produce more louder sounds. And if you want to whisper, and suppose there is an example, if you have expelled all the air in form of a breath, you will be unable to produce a sound. Suppose now I have exhaled all the air from my lungs, which was not in my alveolar sacs. These are the sacs in which air is always filled. So if we exhale, we are unable to produce a sound, because it is the first requirement that if you want to produce the sound, you must have air in your lungs, and it should travel from your lungs to the upper part of your body, coming through throat and so out of the mouth. And if if the air doesn't travel, you will be unable to speak up, you will be unable to produce the sounds. So this is very obvious. You can also practice it. If you exhale, if you if you do expiration, if you take the breath out from the your out from the your out from your lungs, you will be unable to speak, just because of the lack of air inside the lungs. In linguistics, a phone is called voiceless if there is no phonation during its occurrence. Yes, in linguistics, which I have already told that this is the branch of science which deals with the study of language. When a phone is called voiceless, this may be a question that if you want to produce sound, you want to produce sound. Sound can also be understood as phone. If you want to produce phone, and it will be voiceless if the phonation during its if there is no phonation during its occurrence. In speech, voiceless phones are associated with vocal folds that are elongated, highly tensed, and placed laterally abducted than when compared to vocal folds during the phonation. It is very clear from these lines that if you want to produce your sound, if you want to speak up, if someone has to utter, if someone has to talk, his vocal cords should vibrate. They should not be on their place in the as they are normal, if they are not speaking. And if they are talking, if they have to convey their talks to their listeners, they must need to vibrate their vocal cords through the pressure of the air coming out of the lungs to the mouth. And if the pressure of the air is speedily and speedy, if the pressure of the air is speedy, then your phone will have voice. And if the pressure of the air is less, your phone will be voiceless. Fundamental frequency, the main acoustics cue for the perception, can be varied through a variety of means. Perception means understanding, and when we come to hear the different sounds in surrounding, we try to perceive. We can easily perceive that who is talking to us. So this is called perception. Large-scale changes are accomplished by increasing in the tension in the vocal folds through contraction of the cricothyroid thyroid muscle. So, if there are not the contractions in the cricothyroid muscles, your voice will be tensionless. You will produce no sound. You cannot produce the sound effectively. Smaller changes in the tension can be reflected by contraction of the thyrocarotenoid muscles, of changes in relative position of the thyroid and cricoid cartilage, as many occur when the larynx is lowered or raised, either uh, voluntarily or through movement. The tongue, which the larynx is attached via the hyoid bone. In addition to the tension changes, fundamental frequency is also affected by the process, but the pressure drop across the larynx, which is mostly affected by the pressure in the lungs, and will also vary with the distance between the vocal folds. Variation in the fundamental frequency is used linguistically to produce the intonation sound, intonation and tone. The process, there are basically the two terms, the intonation and tone. Tone is actually the accent, the way a person speaks and talks, and that's why we can identify that who is talking to us. And intonation means the way to produce the sound, relating to the phonation is also named as intonation. These can be the sounds which can be perceived and understood through inferring, through perception, through judgment. There are currently two main theories as to how vibrating of the vocal folds is initiated: the myoelastic theory and the aerodynamic theory. These two theories are not in contention with one another, and it is quite possible that both theories are true and operating simultaneously to initiate and maintain the vibrations. These are two theories, and there is no clash between these theories. The point of the discussion is same for both theories, that there is a particular way to produce the sounds. They don't, go against each other. These theories basically work on the same principle. These are myoelastic theory and aerodynamic theory. Bioelastic and aerodynamic theory, let's try to know the difference. Let's try to know the working procedure and the main principle of these theories on which these theories rely. So, the elastic theory states that when the vocal cords are brought together and breath pressure is applied to them. So, in the myoelastic theory, which states that when the vocal cords are brought together and breath pressure is applied to them, and here the pressure of breath is also applied to them, the cords remain closed until the pressure beneath them, the subglottic pressure, is sufficient to push them apart. It is not only the air pressure which actually makes them depart or open. It is basically the subglottic pressure beneath them which is sufficiently to push them apart. So, subglottic pressure, it also subglottic pressure is sufficient to push the vocal cords apart. Apart means when two things are together, and we are going to depart them, allowing air to escape and reduce the pressure enough for the muscle tension required to pull the folds back together again. The pressure builds up once again until the cords are pushed apart, and the whole cycle keeps repeating itself. The rate at which the cords open and close, the number of cycles per second, determine the pitch of the phonation. Here you can easily understand that the process is, the pressure builds up once again until the cords are pushed apart. This pressure goes on working, goes on increasing and decreasing the size and the anatomical structures of the vocal cords, and this cycle repeats, because whenever you talk, whenever you speak, this is the same procedure through which we have to pass through, and our vocal cords react in return, and so hence is the sound produced. Now discuss the next theory. The aerodynamic theory is based on the Bernoulli's energy law in fluids. Bernoulli's energies law in fluids is a basically a theorem and a practical of how sound is produced in physics. The theory states that when a stream of breath is flowing through the glottis, while therein arytenoid cartilage are held together by the action of the interarytenoid muscles, a push-pull effect is created on the vocal fold tissues that maintains self-sustained oscillations. Yes, there is basically the push-pull process in the vocal folds, and this pull and push pressure allows the vocal folds to vibrate, and they start and they sustain oscillations, and through these oscillations a peculiar type of and a specific type of the sound is produced. To push occurs during glottal opening when the glottis is convergent, and the pull occurs during glottal closing when the glottis is divergent. Such an effect causes a transfer of energy from airflow to the vocal fold tissue, which overcomes losses by dissipation and sustain the oscillation. The amount of lung pressure needed to begin the phonation is defined by Tietze as the oscillation threshold pressure. So here we want to discuss that the threshold pressure is actually a responsible thing to oscillate the vocal folds, and uh, the pressure of the lungs needed to begin the phonation is defined as states. Lungs also put a pressure through the air excreting from them. During glottal closure, the airflow is cut off until breath pressure pushes the folds apart and flow starts up again, causing the cycle to repeat. Vocal cords vibrating but more stiffly than in model voice. And if the vocal cords are completely relaxed with the arytenoid cartilage apart for maximum airflow, the cords do not vibrate. So this is voiceless phonation. The voiceless phonation also means that there is a particular number of people around us who are unable to speak, and there is basically a scientific proof that why they are unable to speak up, why are they unable to talk to the people around them, because their vocal cords don't vibrate, and there is a lack of vibration between the vocal cords. This can also be a cause and a source of abnormal anatomical changes and variations in the vocal cords. If the vocal cords are completely relaxed and with the arytenoid cartilage apart from maximum airflow, the cords don't vibrate. This is termed as voiceless phonation and is extremely common with obstruents. Obstruents means where there are obstructions and some type of resistances. If the arytenoids are pressed together for glottal closure, the vocal cords block the airstream, producing stop sounds such as the glottal stop. In between, there is a sweet spot of maximum vibration. Also, the existence of an optimal glottal shape for ease of phonation has been shown, at which the lung pressure required to initiate the vocal cord vibration is minimum. This is model voice and is the normal state for vowels and sonants, sonorants in all words language. If the arytenoid cartilages are parted to admit turbulent airflow, the result is whisper phonation. If the vocal folds are abducted and whispery voice phonation, there are murmurs. If the vocal folds vibrate modally. Here we are going to discuss sounds and their and how the sound is produced. Sometimes we just whisper and sometimes we have to speak loudly. So, if the arytenoid cartilage are parted to admit turbulent airflow, the result is whisper phonation. If the vocal folds are abducted, and whispery voice phonation, which can also be termed as murmur, if the vocal folds vibrate modally. The vocal folds or cords are two flaps of tissues attached to the cartilage of the larynx or voice box. Larynx is also known as voice box. Muscles can move the cartilage in order to adjust the position and tension of the vocal folds. Segments with vocal fold vibrations are voiced, all others are voiceless. Those segments which are basically the talks, if the talks are related to the vocal fold vibration, then we are able to produce voice and we are called voiced. All others are voiceless because the segments of the vocal folds do not vibrate, and so they are voiceless. There's more than one way that the vocal folds can vibrate. There's more than one way they can fail to vibrate. There are multiple reasons because as in the very beginning I tried my level best to make my students conscious that you are much complex, and if we talk about the structure and anatomical requirements and demands of your throat and voice box and vocal cords, there are basically some technicalities. So if if I say you are complex, it means that how much complex you are made up of. And your vocal cords and your glottis, epiglottis, all these things are very special in order to produce the sounds. There's more than one way the vocal folds can vibrate. Yes, there are multiple reasons that vocal cords can vibrate. Suppose you are to speak a different language, which is not your mother language. So this will only be fruitful and only be due to the vibrations of vocal folds. Suppose you suppose you have to speak any other language of the world, and you are unaware and you are unable to speak, but if you try to speak, you will try to imitate them, you will try to copy them. So there will be a time when you will be able to speak like native persons. But there is only one thing that enables you to speak up. This is basically this is basically the vibration of vocal folds. Vocal folds, there is also a chance that vocal folds cannot vibrate. So there can also be the multiple reasons. There are several reasons that our vocal folds are not vibrating, and hence they are not vibrating. We are unable to speak and utter what we want to convey to our listeners. Not vibrating or glottal stop. The vocal folds are held together without vibrating. No air escapes from the lungs. the local folds pulled as the apart as possible. This was all about voiceless. The vocal folds are too far apart to vibrate. Yes, too far apart means too far away, but close enough that they can cause some turbulence in the airstream under the right circumstances. This is what voiceless is called. Modal voicing. The vocal folds are held together along their full length with enough tension to allow vibration. The vocal folds momentarily block airflow from the lungs. The air pressure underneath the vocal folds increases. The increased pressure forces the vocal folds up and apart. Breathy voice. Sometimes you are speaking, but your listeners can easily understand that you are suffocated. So it can also be understood as murmurs. These are basically the abnormal sounds. The vocal cords are vibrating, but there is also a significant amount of air escaping through the glottis, causing the turbulence. Creaky voice. In creak, only the front part of the vocal folds is vibrating, giving a very low frequency. The speaking at the lowest pitch you can then go even lower. The very lower frequency vibration of creak can be superimposed on modal voicing, producing creaky voice. Articulation disorders. There are certain type of disorders which don't help you in phonating. These are called articulation disorders. There is a basically a specific time when you were used to be a very baby boy or a baby girl, you were unable to articulate, but later with the passage of time you started speaking some words your parents used to say. So you started to articulate means you are able to produce sounds. If you are doing articulation, you mean you are going to speak. So there might be some problems that sometimes people cannot speak, they cannot talk properly, and sometimes their voice stumbles over. There is a pause while they are talking, the air stops, and then with the pressure it pushes, it comes out from your lungs to the throat, and so again vibrates the vocal folds and you are able to speak. This can also be a problem of articulation. So we are going to discuss articulation disorders. Roughly the distinction between filter and source. The goal of much therapy is to help the client gain an appropriate use of modal voicing. Modal voicing is how someone has to speak normally, someone has to speak up normally, someone has to talk to persons normally. So, this can be termed as modal voicing. Voice quality is often also used to describe aspects of the filter, specifically vocal tract settings that persist forward than it normally is in the speech community. Some people will say that the utterance has, has palatalized voice. Palatalized voice is voice when someone doesn't produce the very clear sounds. You have experienced such people in your life. Even I have experienced such people in my voice who have palatalized voices. their voice stumbles over. They when they talk, words do not come out of their mouths. We seem that, and it really seems that words have stuck into their throats. So this type of voice can be said as palatalized voice. Phonation is basically the production and utterance of speech sounds. You know, phonation or voicing begins when air is pushed from the lungs through the glottis, which is the opening between the vocal folds located in the larynx. The vocal folds consist of a pair of ligament and muscles that stretch over the larynx opening like guitar strings over the sound hole. These lines are very easy and can easily be explained that the phonation is a production of utterance of speech. Phonation is only speaking up the words, speaking up the sounds, producing production of the sounds. The second name and the alternative name for phonation is voicing, and it begins when air is pushed from the lungs through the glottis. Glottis opens. Glottis is the basically opening between the vocal cords and vocal folds located in the larynx. The vocal folds consists of a pair of ligaments and muscles that stretch over the larynx, opening the guitar strings. The larynx is the top of the windpipe that allows air to travel in and out of. By pushing air through the glottis, the vocal folds vibrate, which produces sound. If the larynx appears closed, there is sound being produced. If the larynx is open, there is no sound. So it is very clear point. Let's discuss it again. If the larynx appears closed, there is sound being produced. It means that if the larynx of your throat, larynx or voice box of your throat appears closed, when it is kept closed, and then after vibration, when it closes, then you are able to produce a sound. And if it remains opened, there will be no sound. You will be unable to produce a sound. So as you know, it entirely depends upon the larynx, which is basically the voice box. It can understood as the voice box. So if it seems closed, there is there is sound being produced, and if larynx is open, there is no sound at all. The physical process. So how exactly does phonation work? To begin with, air is brought into the lungs. Yes, this is how physically we can perceive how sound is produced. So let us discuss exactly what happens with the air, and what type of physical activities are involved in phonation or in the production of the sounds. To begin with, air is brought into the lungs. So if you have to speak up even a single word, you have to bring air into your lungs. Without air, you can't produce sound. If you have no air in your lungs, you will be unable to produce sounds. Suppose you totally exhale and there is no breaths remaining in the lungs, you will say no word. You will be absolutely unable to utter a single word as well. So try letting out a huge breath and then saying something. If you really practice this line, that if you try to get out a huge breath and then you say something, you will be unable to say something. You will not say something because you have no air remaining in your lungs. And you know, sound is only produced when air gets back to the throat and passes through the mouth. So this results in production of the sound. It does not work very well, does it? If you really did try to do it. This is basically an experience for you. If you exhale, suppose in such a way, okay. Now I could not say anything, just because I had expelled all my breaths outside of my mouth from my lungs. So no air was almost remaining in my air, although there are sacs of air. Okay, the more sound you want to produce, the more air you need to start with. That's why singers take a big breaths before beginning a song, and why you need more air to yell than to whisper. You also need, when you are crying, when you are yelling, when you are making making noisy sounds, you are going to produce something. Okay, here I have also exemplified. This is basically the structure, epiglottis, and along with some of the explanations, hyoid bone, thyroid cartilage. Let's watch the structure: epiglottis, hyoid bone, thyroid cartilage, vestibular fold, cricoid cartilage, vocal folds. Here are the vocal folds. These only vibrate, so we are able to produce the sound. And here are the trachea. These can be very obvious. When you touch the neck, you will notice these trachea. These are also made up of cartilage bone, which is softer bone as compared to hard bones of our body. Corniculate cartilage. These bones help in production of the sound. These bones vibrate, and these bones are linked with the pharyngeal muscles and laryngeal muscles with the help of tendons and ligaments. Now, here the entire procedure starts. You know, when we do inhalation, when we breathe in, we get maximum amount of air in our lungs through the respiratory passage, and air is sent to the lungs, where it is again where again when heart pumps and heart sends blood to the lungs, and through aorta it mixes oxygenated blood and conveys the oxygenated blood to the entire body. But if we want to talk, so our talk starts from here. Our the air is present every time in our lungs. When it is pushed back from lungs to the mouth, here it passes through the larynx, which is basically the voice box, and here are vocal folds vibrate, and through the vibrations and oscillations of the vocal folds, which can also be known as vocal cords, due to vibration we produce sound, and this is known as phonation. This can also be said as voicing. So if you are not if you have empty lungs, if you have exhaled, in other words, and your lungs are empty now and there is no more air in your lungs, then you will be unable to produce a sound, because the first thing which is required is to have air in our lungs, and air should pass through this track, and it should vibrate the vocal cords. And if it's not and if the speed of the air pressure is higher, then you will be able to produce louder sounds. If you have to scream, if you have to cry, if you have to rebuke someone, if you have to talk loudly, you must need to push the air pressure towards the upper side of your body, and it should it must pass through your throat and the parts relating to it, and these things resultantly enable us to produce sounds. And if you are going to whisper, you need a little amount of air to be pushed out of the lungs to the mouths. Next one is, okay, when you make a sound, the air from your lungs is pushed up through the glottis, which is the opening between your vocal folds, sometimes called vocal cords. Vocal folds are membranes stretched across the larynx, and the larynx is the organ that forms a passage to the lungs. The larynx holds the vocal folds and the glottis. Here is again a diagram. Let's discuss it. This is basically larynx. The entire area is larynx, and there are basically laryngeal skeleton. There is basically laryngeal skeleton, and these are trachea. This is esophagus and subglottis. Here are the vocal cords. This is glottis and supraglottis and epiglottis. Some people are in linguistics. With reference to the linguistics, some people speak multiple languages. This term is known as polyglottis. So for your information, our 100 orofacial muscles involve while we are producing the sound. So let's watch the next. Let's discuss the next slide I have created. Yes, okay. We are going to discuss, when air is pushed through the glottis, it causes pressure to drop the larynx. This is this in turn makes the vocal folds vibrate, and this vibration is what produces voicing, another name for physical sound that is produced in this way. So voicing is another name for the production of the sound. This was basically the way how physically the sound is produced, along with the explanation of the diagrams. If you were to look at the vocal folds, okay, if you want to observe the vocal folds, when they are resting, they appear open. So when you are silent, when you are resting, when the vocal cords are resting, they appear opened. So the passage down the larynx is unobstructed. When they are vibrating, the opening appears smaller or even closed, as the tension of the vibrating vocal folds stretches them across in the larynx. Here we can have an example with the diagram, and you will be able to understand what I have written in my slide number 40. So let's discuss. Okay, yes, here this is basically the basic structure of this vocal cords. When vocal cords are in rest, when they are not speaking, when there is no air passing through these vocal cords to speak up or to utter, these seem to be opened. But when the air passes through them, these vocal cords are closed. So when they close, there is a tension between the vocal cords, which results in the production of the sound, and how what should be the pitch of your sound and how louder your sound should be. It entirely depends upon it absolutely depends upon the way you have pushed the air out of your lungs. Okay, now let's discuss the second diagram of vocal cords. Here basically this is the magnified image of vocal cords. Here these are basically the cartilage bones, which help us in speaking the words. So we must be very clear that our structure is much complex. Here I have also displayed larynx anatomy. This is basically the internal anatomy. In next slide, finally, the RAS sound is filtered through a bunch of muscles in the mouth and throat called the vocal tract. These are all the muscles used in language production, such as the tongue, soft palate, hard palate, etc., that make the individual sound that we recognize as language. So, thank you so much for listening.